Hi guys, welcome to part 3, the final question we need to cover in the 2021 mechanics exam. This is question 3, energy. So let's begin. A rider and bike with combined mass of 85 kgs climb 4 meters vertically in 3 seconds while biking up a track. Part A, calculate the average power required. Alright, so the power equation is just work over time. We don't know what the work is, so the first thing we need to do is find work. So the work equation is work equals the force times the distance. We can find the weight force by just going 85 times gravity, 9.8, and then times 4. So the work will just equal the weight force, which is 85 times 9.8. We'll just put that in one bracket to make it clear, times the distance, which is 4 meters, and that will give you 3,332 joules. Okay, I'll just put that into my calculator and make sure. Yep, it is. Okay, and now we can find the power because we're also given the time. So the power will just equal the work, which is 3,332 divided by 3 seconds. So the power will equal 1,110 watts. So this is a merit question. Starting off with the merit question. If you get the correct value for the power, you'll be awarded with a merit. Achieved is correct work, or you can call it potential energy or whatever. So this would be achieved. Or correct power. So maybe you still get this 1,110, but you get something wrong when you're trying to find the work or something. So this can also count if you've only got the 1,110. Okay, next question. The rider bikes over a 4-meter long bridge and stops 3 meters from the end. The bridge has a uniform mass of 700 kgs. The combined mass of the rider and bike is 85 kgs. Part B, state the conditions required for the bridge to be in equilibrium. Okay, it's pretty easy. Basically, no net torques and no net forces. Or you could write net force and net torque must be 0. Okay, any of those points is fine. This is a pretty simple achieved question. So that's achieved or that's achieved. Doesn't matter which way you write it or what you write. Okay, next. Draw labeled arrows to represent all forces acting on the bridge. Alright, so first thing we're going to do is there's going to be a downwards force in the middle of the bridge. Okay, so the rider will provide a downwards force, so we're going to draw a small arrow, and we know this force is 833 newtons because we found that earlier. Now, the bridge is 700 kgs, which means it's going to have a weight force that is much bigger than the rider. So we've got to make sure, and the arrow is going to be from the middle of the bridge, we've got to make sure this arrow is larger arrow, since more weight force. Alright, just gonna rub that little bit out. And we've obviously got the support force. Now the support force from pivot A is going to be longer because this rider here is closer to support A, which means that support A has to have a higher support force for it to be in equilibrium, or for it to be properly balanced out. So that means this support force from B will be smaller. Okay. And that's that question. We've drawn the label arrows on all the bits we need. So, part D, calculate the values of all the forces acting on the bridge. Okay, well, let's just start with the weight forces because they're the easiest thing. So, let's just do the weight forces and then we'll do the support forces, which require a bit more calculations. So, part 1, let's do the weight forces. If we do FW of bridge of bridge, that will just equal what was it, 700, yep, 700 times 9.8, and that will equal 6,860 newtons. And the weight force of the rider equals just its mass, which was, what was its mass? Yeah, 85 kgs. Here we go. 85 times 9.8, 833 newtons. Okay, now we're gonna find part 2, support forces. So this is gonna involve torques and stuff, which is might be confusing for some people, but I'll try and explain it easily. So we'll start with finding A, support force A. Find support A. I'll just call it support force A. Which means if we're trying to find this support force A, we're going to have to make this the pivot point. Okay? Make pivot. So, what we're going to do is we know anti-clockwise torques equals clockwise torques, which means, so the rider here, if we make, let's just pretend this didn't exist, this would be providing an anti-clockwise torque because it would be going like in this direction, okay, when we remove the pivot A. So that's going to be providing an anti-clockwise torque. So we're just going to write its weight force, because we know that the torque, something like that. So it's going to be the 700 times, oh, not 700, 85, sorry. 85 times 9.8 times its distance to the pivot point, which is 3 meters. 3 meters. Okay, now the bridge is also providing a anti-clockwise torque, because when we take away that pivot point, it's also going to go in this direction, because it's going to fall downwards towards the left, you could say. So we're going to add on 700 times 9.8, and its distance to the pivot point, you always go from the middle. So 4 divided by 2 is 2, so the middle is 2 meters. To B is also 2 meters, so that will be times 2, and all of that will equal the support force A, which is providing a clockwise torque. So that will equal FA, or SA, what we called it before, support A. Point A, pivot A, is 4 meters away from point B, because if this is 3 meters and the whole bridge is 4 meters, then that means this gap must be 1 meter. So it's 4 meters away, so FA times 4. So if we put this into our calculator, this will equal 2,499. No, we don't need this bracket actually. Plus 13,720 equals, well, you could just write it FA times 4. So if we do 2,499 plus 13,720, this will give us 16,219 equals FA times 4. So that means FA just equals 16,219 divided by 4. So FA equals, let's put that into my calculator. It will equal 4,054.75 newtons. Now we're going to round it to two significant figures because that's the lowest amount of significant figures in the question. So FA equals 4,100 newtons. Alright, TLCF. Okay, we're not done yet. We still have to find support B, but luckily we're not going to have to go through all this crap again because it's much easier. So, I don't know if I'll be able to... I'll try and cram it in this bit. So, oh my goodness. Okay, we're going to find support B now. I don't know if I can... I'm going to have to make this page longer because it's not... see if I can fit it here maybe. Alright, so... find FB, so support B. Now, to find, once you've found one support force, it's pretty easy to find the other one because we just need to know this rule where the upwards forces equals the downwards forces. Downwards forces. Okay? Don't know why that's there. Which basically means our upwards forces, so we're going to have FA plus FB equals the weight force of the bridge, so BR, plus the rider, which we're just going to call R. So that means 4,100 plus FB equals the weight force of the rider or the bridge, 6,860 plus 833. Well, it's rubbing out by itself because it's too close to the edge. But okay, you know that's 833. It doesn't matter. Let's just go. I'm gonna come over here now because we're running out of room. So if you do that, 4,100. So 680 plus 100. Give me a sec. Okay. So 4,100 plus FB is going to equal 7,693 because that's just 6,860 plus 833. So that means FB, if we move the 4,100 to the other side, it's just going to be this number minus 4,100. So if I go down here, I know it's getting a bit messy, but we've got no room, unfortunately. FB will equal, put it in our calculator, 7,693 minus